All right. Number 83 on page 531 is a word problem. It says a wave is passing by an offshore piling, whatever that is, pipe or something, I guess. The height of the water is modeled by the function, blah, blah, where h is the height of the water and time is measured in seconds. So this is a wave passing by here every few seconds or fractions of a second, I don't know. Find the period of the wave. Well, the period is 2 pi over b. In this case, that is 2 pi over, the period is pi over 10, which is 2 pi over 1 times 10 over pi is 20. Now, if I were to graph this thing, and I don't think it asks me to graph it, but if I were to graph it, you know, the x-axis is the time axis, and time is measured in seconds. And the y-axis is height, and the height is measured in feet. So this period is, you know, the length of time between two, you know, corresponding points of that wave. So the units on that is seconds. So that means, it's a little strange, but I guess that's saying it takes 20 seconds for the wave to go from peak to peak. Seems like a long time for a wave, but maybe these waves are really big, I guess. I don't know. But I think that's the answer, part A. Part B, find the wave height, that is the vertical distance between the trough and the crest of the wave. Okay, so we've never defined wave height before, but they're telling us it's the vertical distance between the crest, which is the top, and the trough, which is the bottom. Well, you know, the amplitude of this thing is 3, so that's 3 units there and 3 units there. So I guess the wave height would be 3 plus 3, or 2 times your A value, absolute value, whatever. It's 6 feet. That's it.